Hey guys, welcome to the video. If you've been following the journey with me, we've been creating an Azure OpenAI .NET application using the Azure OpenAI SDK. I was fortunate enough to go to the Azure Microsoft AI tour in Sydney a couple of weeks ago, and it prompted me to go and take a look at what other options there are for us to look at. Now, one of the main reasons why I started looking at this was we were building an application internally at ASI, and it required us to be very flexible in terms of how we engage the various language models, and we might not be using Azure OpenAI. So how can we quickly pivot? Now, that raised a couple of questions with me. First of all, if how do we architect the solution? What options there are, and you'll see a couple of them on screen, and how we can easily go through all of the options, and how can we switch out, right? The whole point of building modular software is to be able to swap out our applications or pieces of our application quite quickly. So I did what all good consultants do. I drew a whole bunch of pictures, and we're going to go through what the options are for engaging Azure OpenAI in today's video. So let's get started. Okay, so our first option that we're going to look at is Azure OpenAI as it is. Right, I'm just going to move it to the side a bit more. Right, there we go. So this is the one we took a deep dive. I'm going to pin the playlist up top so you can go take a look at those videos. But this is the first option that we looked at, right? And it's got some relatively good .NET tooling. It's available in a whole bunch of avenues. So we've got a TypeScript client, we've got C#, it's got quite impressive Python tooling, and it's got the REST API as well. Now, sadly, the C# component of this is a little bit behind the rest, which seems to be the course, right? That just seems to be how things are going. But it's a good way to get started with the fundamentals. Now, if you know you're only going to use Azure OpenAI, have at it, right? It's a good way. It's a very clean interface. It doesn't need to be overly complicated. If you follow the videos, you'll be able to build out your own chatbot. But a couple of things that is worth pointing out, as considerations if you are going to build out your application using the Azure OpenAI SDKs. First of all, it's a great way to get used to the fundamentals. The object model is pretty straightforward. It's not particularly complex to get used to. The documentation is reasonably good. And importantly, Microsoft has the OpenAI Studio. Now, you need an OpenAI subscription for this. But you can go out and play with the subscription. They give you code samples on how to get, started with your code in a variety of languages. So C# sort of a first-class citizen there now. And probably the coolest thing that's released recently was that Microsoft's now brought out the Assistants API, which does change how you work with this a little bit, but it is a relatively good way to get used to it. Now, probably the risks or the drawbacks of this particular approach. First of all, it can be a little bit difficult to extend because you have to build out everything. You have to consider your own port exhaustion because you're basically putting HTTP call after HTTP call to the OpenAI server. So you need to think about how you handle that and memory usage in your application. And you need architect. We're going to go through architecture at the end of the video about how I'm approaching this personally. And once again, just a call out on this video, a lot of this stuff's opinion, just based on my research. So I would love to hear your comments if you've seen a different way of doing this, if you're using a different approach, if I'm losing the plot. So yeah, feel free to give your comments. But the first one to get started, as I said, OpenAI Studio with the SDK, relatively good to use. It's cross-platform, it's pretty good to use. The OpenAI Studio is immensely powerful to get going, and you would need to use this OpenAI Studio to go and deploy your language models in any way. In the language or in the studio, you do have access to DALL-E as well, so you can go and play out with that. So a good option to get started. The second one that we're going to look at today is the Semantic Kernel. Now, this is an open source initiative driven by the community. It's got a very strong C# and Python sort of community support. From my interpretation of this, it's basically micro C#'s answer to LangChain, which you're going to take a look at next. And it's basically built around this concept that you've got the kernel. So you instantiate a kernel and you would go and configure all your prompts, all your safety, all your actions, and they call them planners to sort of understand how the bot would react. It's a very, very, very exciting platform. It is one that I'm currently doing a bit of a deep dive in to understand, to bring you guys some more content alongside PromptFlow. And one of the cool things here is, well, one of the cool things is that you're not limited to OpenAI. If you've got Hugging Face, if you've got, I'm not sure if Gemini is supported yet, but it's not necessarily an Azure OpenAI specific platform, right? Even though a lot of people have this sort of mental picture that if it's built in C# or something along those lines, or it's using .NET, then it automatically becomes a Microsoft tool. Now, that's not the world we live in anymore. Now, one of the things that's pretty cool about this, as I said, you can go and define your whole persona. Your bot would be, you'd build it out, you would give it your actions. So think function calls or chat tools, and you would go and build out everything that you need to build out. The tricky thing around this is making that shift in terms of the level of complexity, because you are building out a much more rich and verbose model. But more than that, when you start thinking about how do I engage search, whereas with the Azure OpenAI SDK, it is pretty straightforward. I know I'm using cognitive search or AI search, so that's how I need to work with it, right? Here, because it is a more generic approach to this, you have to start getting into the space of thinking about vector databases and those kind of things. Now, I'm going to, as I said, build out a whole series on getting started with Semantic Kernel. I do think from a C# perspective, this is probably the way I'm going to lean in terms of how I build out my applications, because it is a first-class citizen, right? It has dependency injection, so you've got your memory usage. You do not necessarily have to care about stuff like port exhaustion, those kind of things. So it is a very, very good, very robust tool to use in the C# ecosystem. Right, so I cannot make this video without talking about LangChain. At least as far as I can tell, it's the OG of putting together all of these different models and bringing in tools and plugins and those kind of things. I personally have not done a lot in LangChain. I did look at it initially when we were still sort of due to a lack of C# tooling. We looked at this from a TypeScript or from a Node perspective. So we took a look at LangChain JS. But it is, as I said, the OG, and the tooling around this is amazing. The community support around this is amazing. It's not particularly difficult to pick up on. There are a few things, as with the Azure OpenAI SDK, that you need to be aware of, because you're not building out your memory usage, right? Or it's not using .NET dependency injection. You need to care about how many times do you instantiate a new client, because obviously you have to start now caring about this. Now, I'm not the best Python developer, so I'm not exactly sure how that would work in the Python world, but it's almost an honorable mention. You cannot have this kind of video without talking about LangChain. So I'm not going to go into it too much more, because honestly, there's 100,000 videos on YouTube about this, from people that know a whole lot more than I do on this particular topic. So it's a very exciting option, is PromptFlow, right? It's a very, 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 very good option. What it allows you to do is not only go and throw a message into a bot and hope for the best, hope it understands it. It's pretty good, right? So we know we don't necessarily have to worry. But the idea is when I need something that is a bit more specific and a bit more procedural, PromptFlow allows me to grab a message as an API endpoint and actually visually, right, go and route that through a whole series of API calls. I can run it through my own code. I can inject it into Semantic Kernel, which you can inject into PromptFlow. So it gives you a very rich and very, very robust way of working with your LLM applications. Now, it's only Python based for now, which honestly is not a problem, right? Even for a .NET guy like me. Now, the reason for this is, yes, as you can see, it's got native VS Code tooling. I'm currently using the plugin to explore PromptFlow. It is really good. But effectively, you can go and build out a visual flow almost, right? PromptFlow. about your application or the LLM component of your application. And effectively what this becomes is, at the end of the day, an API that you would call. Now this deploys to Docker, which obviously brings in stuff like Azure Kubernetes services, and obviously if you want to run it locally on Docker, you can do that. But it brings in quite a bit of the sort of containerized ecosystem. What's cool about that, and the cool thing that it effectively just translates to YAML with a bunch of Python scripts around it, is that you can follow proper CI/CD principles, right? And you can build this out properly. One of the things which we're going to be covering relatively soon, which is an amazing feature of PromptFlow, is the fact that if I've got a flow that does, let's go and say, get the weather, right? You can build out evaluation flows. So you're using AI to check your AI, right? It's really, really good. I'm not going to go into too much detail, but the whole point around evaluation flows is, if I've got this kind of sort of bot that now needs to run some sort of procedural concept, how can I verify the results, right? Which is one of the biggest things that we've got a problem with in the LLM space, is we do not know necessarily what this bot is going to return. So we need to think about how we can build in these tests. And effectively what that would look like is, I would give it a bunch of prompts with the expected answers, and it would go and run those prompts individually like you would do with your normal test cases, and it would return results, and it would compare the results against the expected answer and see if it's close enough. Really, really cool, amazing tooling. The one thing that I think is probably a little bit of a drawback is the idea that this becomes an isolated piece of kit, right? Now, if you're sort of in a microservices type environment, this works great. The way we're using it internally, in a little bit of a project that we're building out, is the idea that my chat service, which we're going to talk about in a second, actually just instantiates an HTTP client that calls these flows. Now, the one gotcha is, because this is not part of our code base necessarily, these input and output variables, we need to be very careful and very specific with them, right? And you almost need a good game plan around working through what this is going to look like. The reason I say that is that these inputs and outputs that the flow can give you are completely up to you. And if you've got a team of 15, 20, 25 developers all working on pieces of an application, then that is an easy place where people can get, sort of, the wires can get crossed and those kind of things. So the one gotcha, and probably the only thing I can call out, is be very explicit and have a game plan. Almost come up with a standard, especially if you're thinking about chat-based stuff and applications and those kind of things. Then have a standard in your team to use this. Right, so in the spirit of inclusivity, I have to give a bit of a call out to low-code solutions. So obviously Copilot Studio, Microsoft's released this. At ASI, our CISO is actually playing with this as an alternative to not have to build out bots. And honestly, it's very, very good. It allows you to do everything that you would typically expect to do: connect to data, security trim, call actions. And what's really cool about this, it's basically connected to the Power Automate ecosystem, right? So you've got that drag and drop connector type experience. So if you've built a Power Automate flow and you've built a Power Virtual Agent, which is what this used to be, you've now got this option, right, to go and extend what you're doing with your LLM type applications. Now, I released a video a while back where I played around with Copilot, and we built a fully functioning chatbot in less than 60 seconds, right? That's really how fast it goes. But as with all Power Platform type solutions, you need to be very careful in terms of governance, because of every guy in the organization can go and build his own bot. Which version of that bot is going to be correct, right? So just a big call out for, especially on the IT admin side of this, think about how you can govern this, how you can control it, potentially look at limiting what people can do in the default organization or default environment in your organization for Power Platform. And what's really cool about this is you can include this in your Power Platform solutions, right? Which in turn can go through DevOps and those kind of things. So very good option. The only call out there is just watch for sprawl. All right, so last couple of things, just a few lessons learned from the field. And if you are starting off on this journey, then hopefully this will help you a little bit, right? Now, when I say it out loud, it almost feels like common sense, but just a couple of things that caught us out in the beginning as we were experimenting with, different types of LLM options. And it basically comes down to follow good coding practices, right? If you go and build out an API that has a chat endpoint and you build your integration with any one of the options we discussed today into your API, if that changes, you're in trouble, right? It means your whole API needs to get redeployed, or at least that endpoint in a microservices environment. Now, the challenge that you're going to face is the fact that this is still moving really, really fast, right? And yes, you've got tools like SK and LangChain that now make it a little bit easier to manage that. But at the end of the day, it is moving fast, and you do not know, because this is a trap I fell into. You do not know what's going to happen 3 months from now, right? This industry is still moving at a ridiculous pace. So a couple of things that we apply internally. Obviously, we follow domain-driven design. So we actually make the idea of a chat message with citations and a user conversation part of our domain models, where we use LLMs. And we've got a dedicated chat service that is responsible for toggling between the various sort of avenues that we can follow. Right now, what that looks like is we've got some front end that talks to some API that we've built. And from a front end perspective, that's all it knows. It knows I'm going to send a message and I'm going to get a message back, right? I'm going to get text and get text back, or send text and get text back. Now, in the API, we typically build out a chat service, and that chat service would contain a message and potentially at least a citation class. Um, and in the chat service, or first of all, we've got a chat factory, and that chat factory says, all right, well, understand which sort of endpoint we need to go to, right? So we can pass the endpoint as either a prompt flow endpoint, or we've built out a semantic kernel API, whatever the case might be. We then pivot, and then depending on what sort of implementation we have on the right hand side, we either use the HTTP client, or we can just instantiate a version of this interface where it is sending a message, sending it or streaming a message, and those kind of things, right? But because at the end of the day, everything that happens in between, the function calling, the data lookup, all those kind of things, we want to abstract that from our main application as far as possible, because we want that to evolve without having to affect our main application. Um, so typically the flow we go with is, as we can see on the top here, all we pass to the LLM is the conversation history and the particular message that the user sent now. And then all the way back, the LLM basically sends an API, or does all it needs to do with that particular message. And we're just expecting that we're going to get something that looks like a message response back, which might have message content, it might have citations, and those kind of things. The fact that it called a function to go and call the weather, right? We don't care, right? That's the whole point of the LLM, is we want to abstract that from our application and make that evolve on its own. The chat service just is literally like a switchboard. So that's it, guys. I'm going to zoom out a little bit and unhide this so you can take a look at it. But that's basically it for today. I know it was a bit of a whirlwind tour. In the coming videos, we are going to look at prompt flow and semantic kernel, because those are the two things that I'm sort of exploring in a big way now. If you're interested, we can do some low-code stuff in Copilot Studio. That's also an option. Let me know in the comments. Like, subscribe, hit the bell, all those YouTube things, and I hope to see you guys in the next video. Cheers.